right, today the focus is on zero product property. So you have a warm-up on the screen. Let's go ahead and solve. All right, welcome back. I am willing to bet that there are probably a good number of you that went ahead and looked at this problem and said, hey, that's easy. 8x squared plus 4, 8x squared minus 4. I have perfect squares on both sides of the operation sign, so it's got to be difference of squares. Now, that would be a great observation had this been a subtraction sign which indicates difference. Since it's not a subtraction sign, it is not a difference of squares problem. The only thing we can do for this particular problem is factor out the GCF. So the GCF between 16 and 64 is 16. 16 goes into 64 4 times. 16 goes into 1 time. And so our solution is 16 times 4x to the fourth plus 1. The zero product property. The product of two or more numbers is equal to 0 when at least one of the factors is 0. Now you've seen this for years. All the way back to your elementary years where you first were told 0 times 0, oh you saw times that way, sorry, is equal to 0, and 0 times 1 is equal to 0, and 0 times 2 is equal to 0. And so eventually they said 0 times anything is always going to be 0. And so you have had the zero product property in your head, practically speaking, for years. So we do know that 4 times 0 is 0. We also know that 5 times 0.06 times 0 is still 0, which means I don't even care what 5 times 0.06 is, because the moment that I realize I'm going to be multiplying that value by 0, the entire statement is 0. That's good for us to know. So our directions. We are trying to solve to figure out what I can plug into this pair of products that's going to give me a value of 0. And typically this is one of the easiest ones that students look at the screen and say, oh, Mr. Gable, if you plug a 4 in there and subtract 4, then you get 0 times x plus 9, and 0 times anything is equal to 0. That is absolutely true. So x equals 4 is one of our options, one of our solutions. Now at the same time, let's get rid of all of that. We can plug in a negative 9 for x plus 9 gives us 0. And if I multiply x minus 4 times 0, we still get 0. So x is equal to negative 9. Now the question becomes, is x 4 or is x negative 9? The answer is yes. It's both. But now is a really good time of figuring out what our work should look like, because obviously I don't want your chicken scratch all over the page like this. This was just us talking about how the problem would be solved. We're going to start with x minus 4, x plus 9 equals 0. And so we want to know what is going to make each of these binomials 0. So we'll start with one of our solutions. X minus 4 is equal to 0. We'll add 4 to both sides, and x will equal to 4. Then we'll do a little bit of work for the other solution. X plus 9 is equal to 0. We'll subtract 9 from both sides, and x is equal to negative 9. Now you'll notice on one side I showed the work subtracting 9. On the other side I did not show the work adding 4 to both sides. You guys are at the point where I can follow your work pretty well as long as I can see one step at a time. Don't try to think that you're going to be solving or adding 4, multiplying by 2, subtracting 5, squaring something all in one step. I need to see individual steps. So no, you do not have to show me that you are subtracting 9 from both sides to keep it balanced. You can certainly go from that step to that step and be just fine. 2x plus 11 times 3x minus 9 is equal to 0. Now's where it starts to get a little bit more complicated, because we don't just look at the problem and simply say, oh, I know what the solution is there. No, we have two factors, something being multiplied by something. If one of these factors were to become 0, it would make the entire statement 0. So 3x minus 9 is equal to 0. Let's make one of the factors 0. We'll add 9 to both sides. So 3x is equal to 9, and we will divide by 3. So x is equal to 3. X is equal to 3. If I plug in a 3 for x, and notice I can plug in 3 for all of my x's, 2 times 3 plus 11 times 3 times 3 minus 9 equals 0. 2 times 3 is 6 plus 11 is 17. 3 times 3 is 9 minus 9 is 0. So now all of a sudden we have 17 times 0 equals 0. 17 times 0 is in fact 0, which equals 0, so we're good. We've checked our solution. But is x equals 3 the only solution that will make this particular problem 0? No. Let's figure out the other one. We want to take our other factor and set it equal to 0. 2x plus 11 is equal to 0. Subtract 11 from both sides, and 2x is equal to negative 11. Divide by 2 on both sides, and x is equal to negative 11 halves. So now we have two solutions. X squared plus 12x plus 35. Now, we could certainly start guessing at what values x could be. So let's plug in a 0. 0 squared is 0 plus 12 times 0. Well, that's 0. So 0 plus 0 is 0 plus 35 is not 0. 1. 1 squared is 1 plus 1 times 12 is 12. So 12 plus 35 is 47. I'm going in the wrong direction. We could guess and check all day and eventually get it right. Or we can save ourselves some time, go ahead and factor this down and know what our solutions are going to be really quickly. So we need two numbers that add up to 12, multiply together to give us 35. Hopefully we're thinking 5 and 7. Now, my leading coefficient here is 1, so these are my factors. X plus 5, x plus 7. If I multiply those together, I get x squared plus 12x plus 35. So that's equivalent equals 0. Well, at this point, all I have to do is figure out what value of x is going to make one product 0, what value of x is going to make the other term 0, and we're good. So x plus 5 is equal to 0. Subtract 5. X is equal to negative 5. X plus 7 is equal to 0. Subtract 7. So x is equal to negative 7. And those are my two solutions. All right, 4x squared minus 81. All right, now this time I do have a subtraction sign, and I have perfect squares on either side. So this is a great difference of squares problem. 2x plus 9, 2x minus 9 equals 0. And so we're going to set each product equal to 0. 2x plus 9 equals 0. Subtract 9, so 2x is equal to negative 9. Divide by 2, so x is equal to negative 9 over 2. That's one product. Now let's take the other product and set it equal to 0. 2x minus 9 equals 0. Add 9 to both sides, so 2x is equal to 9. Divide by 2, so x is equal to 9 over 2. And we've created two solutions, negative 9 over 2 and 9 over 2. Ooh. Now, some of you in class were able to guess at the number of x. Because if we plug in a 0, 0 cubed is 0, 0 squared is 0. Oh, wait a minute, that doesn't work. Let's try a 1. 1 is 1 plus 1 plus 1. No, that doesn't work either. Let's try negative 1. Negative 1 plus 1, that's 0. Negative 1 plus 1, that's 0. So, yeah, negative 1 would be a solution. But you'd be in trouble if we leave negative 1 as our only solution. Let's see why. So we have x we're going to solve this by grouping. X cubed, so x squared will be our factor, x plus 1. All right, our GCF there is positive 1, so x plus 1 equals 0. So we end up with x plus 1 twice. That means that is one of our solutions. X squared plus 1. Oh, that's another solution. All right, let's set these solutions equal to 0. X plus 1 equals 0, so we subtract 1. X is equal to negative 1. We already discussed that solution, but let's look at the other. X squared plus 1 is equal to 0. Subtract 1, so x squared is equal to negative 1. And now all of a sudden we're into a scenario where when I take the square root of one side and the square root of the other, I realize, hey, I can't really take the square root of a negative 1, can we? So x is now equal to plus or minus 1i. And imaginary numbers is not anything we're going to get into right now, so most of your solutions will not notice that. What I need for you to know right now is that you have a solution of x equals negative 1, and we can ignore the other solution, just say that it doesn't qualify. All right, x cubed plus x squared is equal to 0. Ooh. Hey, we have a GCF. X squared is our GCF. So we're left with x plus 1 as our other factor. Remember, x squared is one factor. It's getting multiplied to x plus 1, a second factor, equals 0. So we're going to set each factor equal to 0. X squared equals 0. Square root. X is still equal to 0 because 0 times 0 is equals 0. All right, let's set our other factor equal to 0. X plus 1 equals 0. Subtract 1, so x is equal to negative 1. I have one factor, I have a second factor, and we are good to go.